the part 2 of electronegativity, bond polarity, and also dipole moment. So in this part 2, we are going to discuss about the types of chemical bonds. Okay, so how many types of chemical bonds that we have? Okay, for the types of chemical bonds, okay, we have 3 types. Okay, first one is the ionic bond, second one is the covalent bond, and third one we have metallic bond. So metallic bond, we have a special topic just for metallic bond. So in this topic, we are going to discuss more on ionic bond and also covalent bond. For the first one is ionic bond. This ionic bond is actually occurred between metal and also non-metal, where we have the transfer of electrons between cation and also anion. For example here, let me show you for the ionic bond. Okay, so the formation of sodium chloride, we have Na plus, sodium plus, this is the metal, and we have a chloride, this is the non-metal, to form NaCl. Okay, or you can write it down as Na plus and also Cl minus. Okay, alright, so this transfer of electron, one is positive and one is negative, it will form sodium chloride, okay, between the metal and non-metal. Second one, okay, we have covalent bond. This is where we have a sharing of electrons. Okay, we have 2 situations here. First one, if we have the 2 identical atoms, okay, form a covalent bond, each atom usually has an equal share of the bond's electron pair. While for the second one, let's say we have different kinds of atoms combined. One of the nuclei usually attracts the electrons in the bond more strongly. Okay, let's look at the example for the first situation and the second situation. So if we have the same atoms sharing electrons, okay, for example, we have hydrogen, H2. Okay, alright, so this is the formation of the hydrogen. Sharing of electron between hydrogen, okay, first hydrogen and also second hydrogen, okay, in order to form the H2, or usually we write it down as like this, okay, or H, one single bond, H. So one hydrogen atom share its one electron, while for the hydrogen here also sharing one electron. So the electron density of the electron pair in the bond is spread evenly, okay, between these 2 hydrogen atoms in H2, which give a non-polar covalent bond, or this is where we have the sigma bond. Okay, why this is called as non-polar? Because we don't have any difference in electronegativity. Okay, right. Second one, our second situation, let's say we have different kinds of atoms. For example, we have one hydrogen here, this hydrogen share one electron, and the chloride, okay, or the chlorine here, the valence electron of the chlorine here is 7. Okay, right, and then so hydrogen can share one electron, while for the chlorine need to accept one or need to share 7 electrons here, okay, to form hydrogen chloride or hydrochloric acid. Okay, so this interaction or sharing of electron between hydrogen and chlorine here will give a 1 sigma bond. Okay, so the electron density of the bond in HCl is pulled together, is pulled more tightly around the chlorine, and okay, of the molecule, giving a partially separation of charge and a polar covalent bond. While because we have difference in electronegativity, this is delta positive while this is delta negative. Okay, more electron cloud here surrounding the chlorine compared to the hydrogen. Okay, because this is positive and this is negative. But what happened to the electron cloud between these two hydrogen in H2? They are the same because we don't have any difference between these two hydrogens compared to this hydrogen and chlorine. So because we have the difference between delta positive and the negative here, we can call it as polar covalent bond, while this one we call it as non-polar covalent bond. Okay, so here we have 1 sigma. We have 1 sigma. This is also 1 sigma because a single bond. While for the triple bond, we have 2 pi and 1 sigma bond. Alright. Okay. Then what happens if the two atoms that constitute a covalent bond are identical? So we have equal sharing of electrons, okay, and we call it as a non-polar covalent bond. This is what I have shown to you in previous slide. Okay, equal sharing of electron from the hydrogen, 1 electron from hydrogen and another one from another hydrogen. So we have equal number, so we don't have any different in terms of the electronegativity, and so what happened, it will give you a non-polar covalent bond. Alright, and while for the ionic bonding and also non-polar covalent bonding, okay, actually represent these two extremes, right? Okay, so we have equal sharing of electrons, and if the two atoms that constitute with a covalent bond, okay, are not identical, okay, we have two different kinds of atoms or elements, okay, then there is an equal sharing of electrons, okay. This is what we call, it will form what we call polar covalent bonding, okay. So one atoms assume a partial positive, we write it down as delta positive charge, while the other one, okay, assumes a partial negative charge, or we write it down as delta negative. Okay, so this charge difference between delta positive and delta negative of the unequal attraction of the atoms have for their shared electron pair. Okay, for example, the easiest example here, we have hydrochloric acid or HCl or hydrogen chloride. One hydrogen here is the delta positive, while for the chlorine here, this is the delta negative. So this is partially positive, this is partially negative, right? And as you know, based on the electronegativity, chlorine has greater attraction because higher of electronegativity values, okay, and it is actually smaller than the hydrogen. Okay, and so the sharing of electron between hydrogen and chlorine here is closer to chlorine than the hydrogen. What happened to the electron cloud between the hydrogen and chlorine here? This is much more smaller, okay, compared to chlorine. So the attractive force that an atom of an element has for shared electrons in a molecule or a polyatomic ion is known as electronegativity. Right? So that's all for part 2, the types of chemical bonding. Okay, so we have discussed about the ionic bond and also covalent bond, and also a bit about non-polar and also polar covalent bond. So guys, I'll see you guys in part 3. Okay, so don't forget to like, comment and also subscribe my channel. I'll see you guys in part 3. Bye!